In the past 4 years, you've graphed a lot of different functions. You've graphed lines, parabolas, so quadratic functions, cubic functions, rational functions, exponential and logarithmic functions. A function that you may not have graphed just yet are the trigonometric functions, like the sine, the cosine, and the tangent. That's what we're going to explore in step 29. As you can see, these sine and cosine functions just look like a giant squiggle, and they are placed in different points on the graph. We're going to actually slide down in our notes here and practice graphing them ourselves. If you were to make a t-table and you took the sine of 0, so here's x and here's y. When x is 0, the sine of 0 is 1. You could type that on your calculator. Or, excuse me, I misspoke. I'm thinking about cosine already. The sine of 0 is 0. You put it right here at the origin. If you put in 90 degrees, the sine of 90 degrees is 1. Next up, we have 180. When x is 180, the sine of 180 degrees is 0. And 270, the sine of 270 is also negative 1, right about here. Putting in 360 degrees, the sine of 360 degrees, and again, if your calculator is in degree mode and you test this out, you would get these values. It's 360. So when we gently connect these points that we've plotted, this is our sine function. Similarly, we can do the same with cosine. Again, you could make a t-table. You can even just plug this into Desmos and graph it. We are currently graphing what are called the parent functions, where there are no other coefficients or transformations applied to these functions. This is just the basic function. Cosine is going to look very similar to sine. In fact, I'm going to try to smooth this out just a little bit if I can. And it would continue on in both directions infinitely. The cosine function has the same shape, but it has a different location. So instead of starting here like the sine function, the cosine of 0 is actually 1. So it would be located here. Looks like I missed the mark a little bit when I was placing this. So I'm going to try to redo it here for you. The cosine of 0 is 1. Cosine of 90 is 0. Cosine of 180 is negative 1. 270, 360 would be back up here at 1. So this curve comes down, goes up, and so on in both directions infinitely. The domain, because it goes to the left and the right infinitely, is from negative infinity to positive infinity for both of these functions. The range, if we're looking at these functions and thinking, how high up does it go? How far down does it go? Same with the cosine. How high up on the y-axis does it reach? How far down on the y-axis does it reach? We can see that these are from negative 1 to positive 1. Including negative 1 and positive 1. Now the notes at the top of the page have the same thing. We just usually write negative infinity to positive infinity, and we usually write our range. What you see here is set notation. We like interval notation a little bit better. It means the same thing. Talking about amplitude, that's talking kind of about like the height of these little curves. And we only start at the axis and count up. So from here to here, that's a distance of 1. You could also count down from the axis to the very lowest point is also a distance of 1. So the amplitude is 1 for both of these functions. The period, when we say the period, we're talking about how far you would have to graph it until it starts to repeat. So for instance, right here, it goes up, it comes down, goes back up, and then that repeats over and over and over. If I take that yellow curve, I could repeat it right here. It would repeat over and over and over, or on this side of it. But the part that repeats is the period. So it repeats going from 0 to 360 degrees. So we say that the period is 360 degrees. Same thing is true of our cosine function. It starts here, it goes down and back up, and then that curve repeats over and over and over. So the period of the cosine function is also 360. Taking a look at these parent functions, you can see that they're very similar. It's almost like the sine function has just been shifted a little bit, but they're the same function shape, generally speaking here, when we're talking about the parent functions. I want to talk a little bit about their symmetry. The cosine function is going to be symmetric about the y-axis. So if you could imagine folding the graph right here along that dotted line, the y-axis, the left side of the cosine function would line up on top of the right side of the cosine function. So cosine is symmetric about the line x equals 0, or the y-axis. On the other hand, if we take a look at the sine function, it's symmetric about this line, but we really like to talk about the origin here. The sine function would have rotational symmetry. If you could imagine rotating it 180 degrees, just spinning this function around the origin, or turning or twisting it, it would line up on itself after you rotate it 180 degrees. So the sine function has rotational symmetry. About the origin. Just looking at the equation of a trig function, you can tell what the amplitude and the period are. The amplitude comes from the coefficient at the beginning, right before the function. That gives us our amplitude. So on 1a, you can see here the coefficient there is just non-existent. It's an invisible number 1. So the amplitude for 1a is 1. Looking at 1b, we have a 3 here. So the amplitude is 3. Talking about the period, we look at the coefficient of theta. So now we're inside the function here, and we're looking at that number there. And we basically just follow this formula, 360 degrees divided by the absolute value of b. Right here on 1a, b is 1/2. So if we want to find our period, that's how much of the graph will fit before it repeats. we would take 360 degrees and divide it by the absolute value of 1/2. And when we do that, we get 720 degrees. That's the period. For 1b, we have a number 5. So to calculate the period, we take 360 degrees and divide it by the absolute value of 5. And that will give us 72. In order to graph the sine and cosine functions, again, we have graphing technology like RTI calculators and Desmos, and those are perfectly acceptable to use as we progress through step 29. Again, finding the amplitude here, we know that it's the coefficient, which is 2, and our period is 360 divided by 1, the absolute value of 1 to be specific, which is 360 degrees. Notice it has a period of 360 degrees. It starts here, goes down until it gets to 360, and then it would repeat. It is a bit more stretched vertically because of the amplitude. The amplitude here is 2. If we were to graph the original parent function, it would only go up to 1 and come down and go down to 1. So you can see that this has been a bit stretched vertically because of the change in the amplitude. If it's asking for x-intercepts, you're just looking on the graph, where does it cross the x-axis? So it crosses at 0, 0. It crosses at 180 degrees, 0. And it crosses again at 360, 0. On this next one, the amplitude again is just 1. That's the leading coefficient. To calculate our period, we would take 360 degrees and divide it by the absolute value of 4, because that's our B value. And when we do that, we get 90 degrees. As you can see, if I were to trace this, starting here, I only get to 90 degrees before that would repeat over and over and over. So you can see the period there. And again, the amplitude is 1. If we're looking at the x-intercepts, we can see that it crosses right here and right here, which is a little tricky to read on this graph. So let's go ahead and put it into Desmos so that we can clearly see what those x-intercepts are. Having typed the function into Desmos, we can see right here pi over 8 and 3 pi over 8. So Desmos is reporting these to us in radians, and we want to report our answers in degrees to be consistent. So pi over 8, 3 pi over 8. Let's go ahead and just jot those down for a minute. Pi over 8 and 3 pi over 8. To convert back to degrees, you're just going to multiply these by 180 divided by pi. And you'll quickly see that when you do that, the pi cancels out, which is what we wanted. We don't want any pi in our answer. And then you just do the calculations. When we do 180 over 8, we get 22.5. And when we do 3 times 180, divide that by 8, we get 67.5. Go ahead and pause the video and try 2A and 2B and see how you do. All right, so once you know the amplitude and period, for each of these, you know where they start. Cosine is going to start on the y-axis. Sine is going to start at the origin. If you know that the period is 360, you know you have to fit in an entire repeat between the y-axis and this 360 degrees. And then you know that it has to stretch all the way up to 3 for its amplitude. Again, you can type them right on Desmos to get all the points you need to connect them. But this information here is sufficient to help you graph it. Again, for the sine function, it starts at the origin. I know one repeat of this function, one period, will fit between 0 and 180, which means it's going to cross at 90. And the amplitude is 1/2. So it goes up to 1/2. It actually looks like I may have got it a little bit high, but 1/2. All right.